Welcome. Today's class, we are going to location of centroid G for a semicircular lamina. Some will tell, already over last class. Yes, last class, approach 1 over. Today, approach 2. Suppose this question comes in an examination, either academic or any competitive examination. See, some competitive examination, objective type questions, they will ask only answer. But there are traditional examinations where you are write full answers. That time question can be asked. Derive expression for locating centroid for a semicircular lamina or a lamina in the form of quadrant of a circle. Both we covered last time. Now, last time approach 1 I won't explain. You have taken a strip here at distance y here, that anyway already over. You go through that one. Then I told before that, see, before last class, earlier class, I explained both the approaches. First you should go there. See, now, if you directly come to today's class, some confusion will come. You should go to not previous class, previous to previous class, where I explained both the approaches. With some example also I have given. So now, as usual, first, let R be the radius. See, R is the radius, D be the diameter, C be the center of the circle for which the given lamina is a semicircle. Means, see, this way. I told centroid is G. Let Y bar be distance of G from AB line, base line, AB. See, Y bar. X bar not required because I told axis of symmetry from here to here is either R or D by 2. This you already know it. Now we are finding Y bar now. See, now that Y bar I write here. So this question, to get Y bar, okay. Remember, to get Y bar. That is vertical distance you want. Approach to class. Class means I already explained earlier, not previous class. Before that, I gave all the principles there, the integration, the strips, etc. I explained. Go through it. Consider elemental strip. See, not earlier you have taken strip like this. I don't have to explain once again. How many times I have to tell same thing again and again. Earlier you have taken, see, in approach 1, what you have done? Semicircular. See, you want Y bar this way. So what you have done? You took a strip here, green color, okay. You took a strip here, elemental strip here, thickness dy at y from here. Then formula was integration of dy by area is the formula. Now also formula same. If you want Y bar, it is same formula. Okay, this remove it. It is only what I did last time. Now you consider some other approach. See, this approach is little tricky, but advantage is that integration is easier. See, now, and one more thing, same approach you require later for moment of inertia. At that time, same I will tell at that time. Go back to centroid, class of the centroid, see what all I explained there about the strip, understand correctly, then come here. So at that time, I won't waste time all these things. I will tell at that time. Go back to that class. Okay, start. Consider elemental strip in the form of an arc. See, not this way, in the form of an arc, this way. At radial distance R from center. Center is distance is R. See, here or here does not matter. Radial distance R. Now I'll tell you one thing. Strictly speaking, I'll tell you how it is. See now. Strictly speaking, see, okay. I'll tell how it is. Center C. See now. Elemental strip. See now. Very, 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 very small. Okay. R. That's all. This angle is theta. Later. That's all. With this length, this angle is theta. You cannot see it. It is so small, so small. Okay. Consider elemental strip in the form of an arc at radial distance R from center. Let dr be the thickness of the strip. See, when you take R when you take R this way, any elemental will be along that one. See, earlier, if you take Y this way, thickness is dy. Suppose you take x this way, thickness is dx. When you take radial length r, this is small r, not capital R. See, this r is small r here. Any point, small r, corresponding, see, when this is r, corresponding thickness is dr. As usual, let ds, I won't call breadth because it is arc. ds be the, I written here, see, let ds, where is it? Somewhere I wrote, let ds. Let dr be the thickness of the strip and let ds be arc length of the strip. This arc length is ds. Let theta be the angle made as shown. Whether it is, see, some will ask, sir, is it for this or this one? Both are same, see, both the lines you can see so close. And but one important, see, this is theta, this small angle is d theta. See, let d theta be the angle subtended at center by the elemental strip. See here, elemental strip is here. See, suppose you take elemental strip here, little bigger I will make. See here, elemental strip this way. Then this small angle is d theta, this is theta. That is how mathematics works. When the variable is theta, then correspond, see, when the variable is theta, if you go slightly this way, it is d theta. Now, let it be y. Again, somebody will ask, sir, is y up to here or here? Ayo, what is this? I will ask them. What you are talking, see? I told already, again, next time won't tell. This is radial length r from center. This is a small strip. This is y. This is theta. Don't worry, up to where? Y over. Y you require. So, now lastly, let d theta be the angle subtended at center by the elemental strip. Let dA be the area of the strip. For the strip, area is dA. See, I write everything here. For the strip, area is dA. dA. Let y be the vertical distance of the strip from AB. Why you want vertical distance? Because we want y bar. Then usual formula, y bar from AB equal to integration dA into y by area. Area you know it, pi r square by 2 for semicircle. Now, class, now what you have to do is, we have to replace that y in terms of r and theta. See, as the y changes, r will change. So, and also, see, suppose as the y changes here, as it goes this way, the theta is angle here, radial length will change. So what you do is, you get, see, correctly make a note here. This all you require for understanding purpose. Make a note here. Don't, in exam, don't write this thing. What you do is, this y get in terms of r and theta. Then further, ds also get in terms of r and theta. Even ds also in terms of r and theta. Okay, actually r and not theta, it is actually d theta. Okay, done. First do that one. See, first step. You consider one by one. First you do one thing. See what is ds. We have, write directly, no problem. We have ds equal to, see, ds equal to d theta into r. Why? Because I will give the reason here. See, question mark. If for those people whom it is not clear, I will clarify separately here. See, mathematics once again. If there is an arc length is here, if this is the arc length, if you join to center here, if this is r, we know that arc length equal to radius, ds equal to r, actually I write r d theta, much better. It is actually r d theta is much better. R into d theta. Because formula is arc length equal to radius into angle subtended at center, but compulsorily it should be in radian. Be careful. I should not tell theta be the angle as shown. Very, very important. Theta should be in radian. See, integration, differentiation all, or this, when you take arc length equal to radius into into angle here. See, this is so now here see, this arc length is ds here, ds here. Corresponding angle here is d theta. So this arc length equal to radius into d theta. First of all, this should not be explained. Okay, ds we got. Now, next, ds over. Therefore, dA. What is dA? dA is area of the strip. Now see, since it is very small, you can take as a rectangle of ds into dr. ds into dr. Therefore, your dA will become ds equal to r d theta into dr. See, so we got dA in terms of r and theta. Okay, 1 over. Now, lastly, get the value of y. If this is over, everything is over. Okay. All this I am giving information here. Those who want can do one thing. See, suppose this question comes in exam. What you have to do? You are right. We have ds equal to r d theta. I remove the question mark now. dA, therefore, dA equal to ds arc length into dr. Substituting dA equal to ds equal to r d theta, dA becomes r d theta into dr. Right that way. Now, lastly, see here. To get y in terms of r and theta, see here. Directly right here, see. Light vertical line here. Very minute vertical line. That is y. See. See here. You take this triangle. See here. This is the arc. I'll put a big sketch here to understand meaning of this one. See. This way. This is a small elemental length dr. ds here. This is elemental length. Okay. Center is here. See, then this angle is theta. This is your y. Remember, this is r. So now use trigonometry here. Sin theta, see here, sin theta equal to y divided by r. Therefore, your y will become r sin theta. Here you write directly sin theta equal to, see, sin theta, see here, y divided by r. Therefore, your y becomes r sin theta. This is also over. So we got expression for dA, expression for y, everything is over. Now, happily substitute. Therefore, see here. Therefore, what you want? Y bar from AB equal to, see now, integration and integration, double integration. 1 minute. I will tell the one substitute here. dA, but substituting y bar equal to, see, odd one thing. Y bar from A, B, C, here, see, formula. This is the formula for y bar. Integration of dA into y. Where is dA? dA is actually, formula is what? Formula is integration of dA into y by area. So, I will tell double integration y. dA, where is dA? dA is r d theta into dr, r d theta into dr, r d theta and dr is dA into y is r sin theta, r sin theta. See, r d theta into r d theta into dr is dA. See here. This is your dA. This is your y. This is your y. See, integration of dA into y. Okay, now I'll remove all this. You write a note here if you want. Now, limit. How to put the limit? Okay, I'll remove this one now. See, if you want, you write here. Now, you make this note, then remove this one. Okay. Or r d theta into, okay, now it's clear. dA into y. Now, limit. See, imagine you have to paint. See, for example, just make a note here. There is a surface to be painted. Painting required here. How you paint? Two different ways. Imagine at a time you can paint like this. This much you paint. See, this painting over. Now full painting, what you do? One of the option is continue the painting up to here. That full vertically paint. Paint here. So this vertical painting over. Then horizontally paint here. Horizontally paint here. Or you make a note here. You should make a note. Yeah, later write note. There are two variables here. One of them is r, other is theta. How r varies, how theta varies. Your r is vertical distance. So see here, from here to here, that is radius r, full r. This is capital R. This is capital R. So your r varies from 0 to r equal to capital R. That will finish the vertical painting. See, it will paint fully, it will cover this much, it will cover this much. See, when you integrate from 0 to r, this much painted. Now, this much paint. Theta varies from, see, we have to paint from full this area to be covered. So, theta varies, I should put black color, sorry, r, green color. Value is equal to 0 to make perfectly clear. To this color problem, when I do, to r equal to r. Now, theta, see here, this you have to go for full here. So 0 to 1 full round, theta to 0 and theta to, remember, your limit should be in radian. See, full 180 degrees. 180 degrees means pi radians. So 0 to pi. Okay, now 1 minute. Little later, I am going for, make a note here. Now only make a note. Little later, I am going for location of centroid G for a lamina in the form of a quadrant of a circle. At that time, same sketch will come, but it will stop here. It will stop here. Only change there is, everything will be same. I am not rubbing anything. The theta will vary from, see, if it is a semicircle, theta will vary from 0 to 180 degrees or 0 to pi radians. But when it is semicircle or quadrant of a circle, theta varies from 0 to 90 degrees or 0 to pi by 2 radians. The only change for the next question is this pi will change over to pi by 2. When I do the quadrant of a circle, I will tell, just now I told for semicircle, why it is pi by 2. If you don't, suppose you jump and go further, at that time suppose you skip this one. Later, when I go to quadrant of a circle, I will tell pi by 2. Some will ask, why? Why means go back. See, why, how you can study without going through each and everything. I told I am that type only. So at that time, this pi will change over to pi by 2. That is the only change for quadrant. Over. Now, question is over. Nothing is there. I will finish this question now. See. Now, one make a note here. Here, see, r and theta are independent. Are independent. What you can do is, you can do it equal to, see, integration. Do one thing. You either first, I'll do one thing. I'll take this as it is. Integration r equal to 0 to r equal to what? Anyone r equal to r equal to 0 to r equal to r of one more integration of what? Theta equal to 0 to theta equal to pi. Pi of what? Only theta, see here. Leave r. 1 minute. Instead of that way, what I can do here is, for easy understanding, okay, do one thing here, 0 to r equal to 0 to r, it will be cleanly write here, okay. Or you can write here, equal to, see, do one thing, forget about r. Integration r equal to 0, actually not required this much explanation, to r equal to r. Which r's are there? There is one r here, one more r here. See, r into r is r square into what? dr into integration of theta equal to 0 to theta equal to pi, next time pi by 2, theta equal to pi of sin theta and d theta. This is the expression. Or equal to, see here, integration r equal to 0 to r equal to r of r square into dr into integration of sin theta is cos theta. That much common sense required. Sometime in the class some student will tell, no sir, why? Sir, differentiation of sin theta is cos theta, sir. Okay, integration of sin theta is not cos theta, it is minus cos theta. I will tell, do you think I am not knowing it? You know it, sir. Just for testing you I told. So integration of sin theta is minus cos theta. Be careful, minus cos theta. That much common sense required. See, again, minus cos theta from the limit theta equal to 0 to theta equal to pi. If that much is not known, what I can do? Differentiate sin theta, cos theta, differentiate cos theta minus sin theta, but integrate sin theta minus cos theta. Integrate cos theta, sin theta. If you are not knowing, at least you are knowing now. Or see now, equal to further. Okay, I put here, equal to, see, integration of r equal to 0 to r equal to r of sin theta d theta. Sorry, what is this one? R square dr. Okay, it happens sometimes. R square dr into, see, cos theta pi to 0 minus, you can do one thing, minus bracket. Some small minus is there. Okay, I'll put a flower bracket here. See, minus flower bracket. This is a big bracket. Cos theta, cos pi minus cos 0. 1 minute. I should check the board. Now. Because should not go beyond the camera. There's a space problem here. Yes, no problem. Now do one thing. Little mathematics required. You should know that cos pi is minus 1, cos 0 is 1. See, I think due to ink, it is not proper there. I will write once again. Some ink became dark there. Okay, 1 minute. R square dr. See, R square dr into big bracket, this minus outside, flower bracket, cos pi minus cos 0. Close the bracket, close the flower bracket. Okay, over. See, cos pi is minus 1, cos 0 is 1, or this full value will become minus 1 is minus 2, minus 2 into minus become plus 2. So this full answer is 2, plus 2. Or our integration will now become, see, 2 times, see this 2 will come outside, 2 times integration r equal to 0 to r equal to r of r square dr. R square dr or equal to 2 times of r square becomes r cube by 3 0 to r or equal to 2 times 2 by 3 times 2 by 3 times r cube minus 0 or 2r cube divided by 3 is the numerator. Now you require denominator. I'll do one thing now. Space problem is there. See, I write here now. See, once again, this way. Okay. I think space problem is not there. A little space, okay. Space problem is not there. Nothing to worry. You write systematically the way I explain. Now, denominator. Denominator, that is here, see, that is A. Right here, area of the lamina is pi r square by 2. That much you should know. Area of circle is pi r square by 4. Area of semicircle is pi r square by 2. Therefore, now there is no space. Somewhere here I will write. You continue. Therefore, y bar from AB equal to numerator. Where is it? 2r cube divided by 3 divided by pi r square divided by 2 or equal to 2 into 2 is 4r by 3 pi. This is the same answer we got last time also. So therefore 4r by 3 pi. Now do one thing. 4r by 3 pi or equal to 2d by 3 pi. If you want, make a note here. 2d by 3 pi right here, replacing r by d by 2. If the question is, if they want expression for centroidal distance in terms of what? In terms of diameter, 2d by 3 pi. Now do one thing. Immediately, there is no space here. I write here, see. Anyway, everything is over. One conclusion, I write here now, conclusion. Therefore, space problem, only available space I will write here. Therefore, final answer is, if there is a semicircle here, see, space problem, little big you write, of center C, this is your radius r, this is also radius r, or you can tell r equal to d by 2, full is d. Why you require? Location of centroid. Then centroid will be here. This distance is 4r by 3 pi or 2d by 3 pi. That is your y bar. You write neatly. Space is not there. This sketch last time I wrote. it. See last time question. Last time there was no space problem. I rubbed everything. Therefore, neatly write here. And remember, this is axis of symmetry. Therefore, centroidal distance this way is 4r by 3 pi or 2d by 3 pi. Centroidal distance this way is exactly midpoint. We got exactly same answer as we got by approach 1. You decide now, approach 1 better or approach 2 better. Now I will go for location of centroid G for a lamina, change the language, for a lamina in the form of quadrant of a circle. Space problem here, quadrant, you write correctly, of a circle. New. Let r be the radius, let d be the diameter, let c be the center of the circle for which the lamina is a quadrant of a circle. Is a quadrant. Okay, right. One more sketch here. Okay. No patience to actually use the cloth. Why I am not using? I want to finish this one now. See, put a sketch. This is the quadrant. See, now, this axis, you take AB axis for reference AB, this you take CD. Same EF, not CD, EF. Because this is center C. Centroid is somewhere here. This is your Y bar. This is your X bar. X bar. Remember, and radius is R. One place you write radius R, sufficient. Diameter you cannot see it. Diameter D. Okay. You cannot see diameter. Diameter is D. That is if I complete. Now, last time I told, see, semicircle, one direction, centroid distance is not required. Only one direction is required. Here, not that way. You have to find X bar and Y bar. So, statement, statement required. Let X, first you put up X bar, anything. X bar be distance of CG G from reference axis EF and Y bar be distance of G from reference axis AB as shown. Okay, now of course you write here, because if you turn, nothing will happen. X bar and Y bar both are equal. So therefore, let us find Y bar. Anyone, you can find either X bar or Y bar. Let us find Y bar, because we are already there. Okay, approach number 2. Same statement you are right, but one change now. One minute, I just take the camera. Sometimes suddenly it goes auto. I have to pause and start. No, it's okay. Okay. Everything, same sketch will come. This side is not there. But remember now, why A is the area of lamina. Okay. Then, see, this side is not there. Everything, consider. Write each and everything once again. Just now, thoroughly I explained. You once again go through the explanation, previous explanation, make a neat fair copy. See, everything. This all will remain same. The only change is that, see, R with Y, see, this R, radial distance will vary from Z, Y will vary from what? 0 to R, same way here. Your R will vary from 0 to R. See, here 0, outermost is what? This way. Actually, here or here, wherever you see, radial length is same. See, this is R, this also R. 0 to R. But this theta will be 0 to pi by 2. By 90 degrees. See, 0 here to 90. Now, all I have to do is, you should not do this way. You should write once again, pi by 2, 0. Pi by 2, 1 minute now. This all I remove. Okay, now see. R0, R. R0, R. 0 to pi by 2. 0 to R, 0 to pi by 2. 0 to R, pi by 2. Or R square dr into, it is theta cos pi by 2. See, cos pi by 2 minus cos 0. Cos pi by 2 minus cos 0. That much you can make out. Instead of pi, you get pi by 2. Okay, cos pi by 2 minus 0. Cos pi by 2 is 0. Cos 0 is 1. 0 minus 1 is minus 1. Minus 1 into minus becomes plus 1. It will become plus 1. Or this will become, this 2 will vanish. 1 will come. 1 is not required. 2 will vanish. 2 will vanish. 1. 2 will vanish. R cube by 3. Denominator, area equal to pi r square by 4. Why? Quadrant of a circle. Therefore, okay, everything correct? Any correction? 0 to R, 0 to R, 0 to pi by 2. 0 to R, 0 to pi by 2. 0 to R, pi by 2, pi by 2, pi by 2. Yes. By mistake, if anything is not changed, you change it. Therefore, your Y bar from where? From AB from AB equal to numerator is r cube by 3, denominator is pi r square by 4. Pi r square by 4. Once again your y bar will come here 4r by 3 pi. 4r by 3 pi. Y bar. Right here. That y bar itself equal to x bar. Okay, now over. Everything is over. Last presentation required. I can do now. I can rub everything. Anywhere I can write. Because why? No continuation. Over. Everything is over. Write the answer. Last closing part. See. Now therefore, right here. For a semicircular lamina, you write here. For a semicircular lamina of radius r or diameter, one more thing forgotten here. R, it is equal to 4 into d by 2 by 3 pi replacing r by d by 2. R by d by 2, or this will become equal to 2d by 3 pi. Write it there. That much you can make out, 2d by 3 pi. Therefore, write everything. Quadrant of a circle of radius r, centroid will be here. Centroid will be here. This distance is y bar equal to 4r by 3 pi, capital R, 4r by 3 pi. This is also x bar. X bar also equal to 4r by 3 pi. This is centroid G. R equal to, you can write in terms of diameter, 2d by 3 pi, or equal to 2d by 3 pi. If you want to mark that AB axis here and EF axis here. EF. This is the final result for quadrant of a circle. Last time you got same answer. Now also same. Over. Next class is very, very powerful class. Why I will tell you next time. Okay. That's all. Thank you.